Hey, what's going on, guys? Just gonna run a really quick test. I got 0.25 ohms of a 0.25 ohm resistor through four 1 ohm resistors to test and see how long the driver can be practically left on before I would say it's too hot. It needs to be cooled down with just the heatsink on top of the 8-pin chip that I have. Okay, so I already had this in a Lazeerer, so that's why you see the 1 ohm right here and then 3 1 ohms over here, so that would give you 0.25. Okay, so we're at 1795. Remember, I said in my previous video that the output varies around 30 milliamps. That's just the way the driver is. So I'm hoping for around like 5 minutes. Practical, I don't think a lot of people leave it on longer than 5 minutes, and if you plan on leaving it on longer than 5 minutes, then most of the time it's in a larger build host where it's possible to actually heatsink to this to the diode heatsink, or to the pill, or somewhere heatsink it other than just having the little heatsink that I have on top of the 8-pin chip. Because in a smaller build, for example, like the C6 or something in that nature, the diode heatsink is gonna heat up a lot faster. You're not gonna be able to get 5 minutes of runtime at 1.8 amps without the diode heatsink getting extremely hot. So, I mean, practical 5 minutes on a smaller build where you won't have the option to heatsink it, which you still can heatsink it. All you have to do is just run like a something like this. If you attach it to the top of the 8-pin chip, this, and you cut it to size, you can attach it something like that, like onto the side of the pill, or you can double stack this to hopefully reach. Well, this pill has it cut out, but if you were gonna leave this driver inside the pill and not heatsink it externally, you're gonna want to leave that where the LED goes. You're gonna want to leave that. So what you can do is you can put 2 stacks of some kind of aluminum to reach the inside wall of the LED if this was still here. Okay, so then you would thermal adhesive it to the inside wall, which then you would still be heat sinking it to the pill. If you heat sink it to any pill, you can run it practically 10 minutes, no problem. And I can say just about any pill around this size. This is the stainless steel one, the stainless steel Cree R2 host pill. Even the Cree C3 14500, if you guys seen that pill before, that's enough to heatsink this driver for continuous on. Okay, so the 8-pin. I mean, it's pretty. It's not hot, but it is hot. We've been running around 4 minutes at 1800 milliamps. Okay. I will run this test probably about 10 times, maybe even 15 times. I will run 5 minutes each time because I think that's practical. You know, for a host that is not going to be able to heatsink this unless you're going to heatsink it to the pill, which the diode heatsink will heat up before you would have to turn the laser off before the driver will ever get hot enough to where you have to shut the driver off first, if that makes any sense, in a smaller build. Now in a larger build like this, you know, I'll take some more photos. I heatsinked it to the pill, onto the top part where the LED would go. Now I have enough room in here to do it, so therefore, you know, it's continuous, basically. You know, the diode heatsink is large enough where I can leave this laser on for 5 minutes and not have any issues. Now in a smaller build, you won't have that option. The diode heatsink will heat up before the driver actually needs to be shut off because it's getting too hot. It's staying at the exact same. I mean, I don't have a thermometer to actually test it, but to actually test exactly what it is, but just by the feel of it, I know that's not really a good test, but that's all I have available to me right now. It feels the exact same as it felt when it was at 3 minutes, 4 minutes. We're going on a little over 6 minutes now on. Maybe I'll just run it for 10 minutes just to prove to you guys that this can handle it. Not that anyone's gonna leave their laser on in real life, you know, for 10 minutes. You know, you can also see that it's stabled at 1776 with a 0.25 ohm resistance. Also, this wire is kind of like cheesy. These tracer wires, they're not really that great, so I know it's losing some milliamps through that. So I mean, we're at the point, we're at the about 7.5 minutes, a little bit more, of at 1775, around there. We're at the point around right now that I would say, you know, it's a little overkill to leave your laser on this long. You know, you could just shut it off for a minute, you know, and let it cool down. But just to show you guys that it can handle this is why I'm doing this test. We're a little over 8 minutes now of on time. I was gonna do it just for 5 minutes, but I figured why not just go to 10 minutes. So there's no doubt that just with this little heatsink alone, yes, it does get hot. It does get hot to the touch. You know, it's not how you call it, it's not gonna, it keeps it stable enough, as you can see the output. If you want to keep the driver actually like cool, like room temperature or whatever, like really cool, if that's even possible to keep it at room temperature, you're gonna have to heatsink it to an additional heatsink other than this. The reason why I actually at first put this little heatsink above the 8-pin chip, one, to heatsink the 8-pin a little bit, but also to level out the 8-pin chip with the inductor. So when you're actually going to lay it down on a, I don't know, here's a quarter. If you're actually gonna go lay it down on something flat, there you go, on something flat, the inductor would have been hitting the quarter first, and there would be about, I don't know, maybe a little bit more than 1/8 of an inch gap from the quarter to the 8-pin chip. So by adding this, you're able to lay it flat and thermal adhesive it much better, so it dissipates, you know, because you can't have that much thermal adhesive in between the 8-pin chip and the quarter. It just won't work. It won't be doing a good job. So we're at a little over 10.5 minutes right now, so shut this off. I mean, it is hot. Don't get me wrong, it is hot, but practical to leave it on 10 minutes. I don't see it happening. I mean, you could leave it on. I mean, you just seen I left it on. I'll continue. I'll test this about 10 more times tonight. I'll throw up the video now. I'll start rendering it. I'll throw it up now, and if anything changes, if the driver dies or anything, I'll just update the thread with it. So yeah, yeah. I mean, the driver, as far as touching it, to me, I don't have a thermometer, but to me, it stayed the same, around the same temperature from 4 minutes plus on. So I would say 5 minutes with just this little heatsink is fine. You know, you should have no problem. So 5 minutes, no problem. You know, that's if your diode heatsink can actually be left on for 5 minutes. Okay, so, but best option to do is to actually heatsink it, even if it's just like a quarter. You use a quarter or a nickel or even a penny. That's all that. If you just add like a penny and heatsink that to on top of the heatsink that I have on top of the 8-pin chip and the inductor, that's more than enough that this driver needs to be heatsynced. So I don't know how big this file is going to be for this video, so I might not upload it in HD, but you'll still be able to see it pretty clearly. Alright guys, so I hope this showed you that this driver can handle being left on for quite a long time. Alright, thanks.